So in the transient response, it consists of the three. One is series RL, RC, and RLC. So if I have C that one RL seriously connected, or C seriously connected, or LC is seriously connected, three device or element is connected in series. Then here there is a two derivation. One is a DC source and a no source. I mean free source. I mean no DC source, or another name is called undriven. We were seeing the derivations, followed by RC also DC source. Okay, DC excitation and a free source. Okay. Then today class we look about that RLC. RLC DC excitations. DC excitation, we're going to look it on that one. Okay, this is RLC seriously connected on that one, resistance, inductance and the capacitance, and apply the DC excitations. So DC source is apply on that one RLC. So switch is closed, it means the current is a flow to that this circuits. Okay, so immediately it is a switch is closed means the inductance is inductance and the capacitance, it is taking time to charge the current, taking time to the charge the current. Okay, so this is a derivation, we're going to look it on that as very smallest derivation, and then cases, three cases we're going to look it on that RLC. So as usual we go ahead on that summing up. So summing up, it consists of that one, this is about that summing up. Okay, there is a one step, two step and a three step. Step number three is a consist of the depends on the types of roots wise, case 1, case 2, case 3 consist of that one, that's all. So this is about that you are summing up of that RLC series circuit of the transient. First one, step number 1, we'll look it. So draw series RLC circuits. How to draw the series RLC? So this is about that RLC connected in seriously, you will going to draw. Okay, this is a method. Okay, then first one, write the KVL equation. What is the KVL equation? So voltage rise, it is equal to voltage drop. So suppliers, teacher, it is equal to the students. So teacher is delivering the content, student is observing the content. So so voltage rise, it is equal to the voltage drop. How many voltage drop is there, or how many devices there? Resistance plus inductance plus capacitance. So V1 plus V2 plus V3, it is equal to the V supply voltage. So father is giving the 50 rupees to the three children's. Okay, 20, 20, 10. If they are giving, so 20 plus 20 plus 10, it is equal to the 50. So 50, father is present, father is giving the amount. So this is a source excitation. Okay, then next one. Okay, V is equal to VR plus VL plus VC. Okay, so this is this is a general equation, Kirchhoff voltage law. So Y means this is a three element is connected in series. So okay, then next one, what is VR? VR is nothing but Ohm's law. V is equal to I into R, I into R. So replace into that, VR is equal to I into R. Okay, replace it. Okay, I have replaced it. Then next one, VL. VL is equal to, what is the equation? L dot di by dt. VL is equal to, first unit you were seen in the tabulation. VL is equal to, substitute L dot di by dt. Substitute it. Yes, I have substituted. Then VC. What is a VC? VC is equal to 1 dot by C integration I dot dt. So this is a VC. VC mean voltage across the capacitance. Okay, this one you can substitute. Yes, substituted. Where it is? Yes, substituted. This is the equation number 1. This is the equation number 1. Then what is that one? Next one I want to do, apply d by dt. Apply d by dt means one time differentiate the equations. In the first equations I want to differentiate. Is it directly I will going to substitute, otherwise. So if it is possible you can differentiate, otherwise substitute. Here is I will going to differentiate on the left hand side. So d by dt, any dt is there? No, so 0. Then here, so r dot, so d by dt is a present into the remaining constant plus L dot, here already d by dt is there, so d squared by dt squared dot I plus, then differentiate d by dt in the term. If you're going to differentiate, means the integration of that one time integration, one time differentiation is cancelled. What is the remaining? 1 by c, 1 by c I. Okay, that is constant is 1 by c I. So like you will going to get the equation number 2. So this is the equation number 2, you can complete. And third one, divided by L only. Simply you will going to divide by L on that one, you will going to get the third equations. So in that second equation, divide by L you can do. So left hand side is 0. Okay, then R by L, R dot by L di by dt. Here is L is their numerator, denominator is L, so L is cancelled, d squared I by dt squared, okay, plus here, so coming to that one, 1 divided by L, so divide by L, so 1 divided by LC, this is a constant, into I, it is equal to 0, that's all. Third equation is over. Then fourth one, shorthand. So simplify that one, or shorthand the equation. What to shorthand? D by dt is replaced into the d, that's all. D by dt is replaced into the d. So where is that one? D squared means, okay, d squared by dt squared, so d squared I will go and write. D by dt means d, then nothing, okay, then this is a right. So what is a constant? I is a constant. I will going to move in the outside. That's a, this is the equation number 4. So 4 equation is completed. Okay, 4 equation 1 is a KVL, equation 2 is a apply d by dt, equation 3 is a divide by L, equation 4 is a shorthand I will go to d by dt is replaced into d, that's all. So over about that one, step number 1. The next one I will going to implement the quadratic equation. What is a quadratic equation? Already you were studied in mathematics. Minus b plus or minus b squared minus 4ac divided by 2a. So in that one, B is needed, A is needed, C is A, B, C values needed. Where you will going to get from the fourth equation, what is A, B, C? You will going to take it A, B, C and substitute into the quadratic equation. Find out the K as well, the two term K1 value and K2 value you will going to find out. Find out the K1 term, K2 term you will going to find out. After find out the K1 terms, so substitute on that one. Okay, I will going to tell you next step, I of t. Okay, so first quadratic equation. So this is a general equation formula. Okay, ABC needed. From that fourth equation you will going to take the ABC. So from the fourth equation, what is A1? B R by L, C 1 by LC. I have written here A value, B value, C value. Then quadratic equation I am writing. So D1 value, D2 value I will going to find out. Then substitute A value 1, B value C, what is this one? R by L. Then C value 1 by LC. Substitute in that one. Yes, I have substituted. So divided by what is that one? 2a. 2 into a is a 1. Okay. So this is a coming. Okay. From further I will going to simplify. 2 is there. So simplify. So 2 is going to here. Minus r by 2l plus or minus 2 is going to inside the root. Inside the root. Root of 4. What is answer? Root of 4 means answer is 2. Okay. Root of 4. So I will going to move that one. Okay. So here what is that one? Yes. So here is a 2 is there. This 2 is nothing but here I simplify. I mean I will going to strike out here. I will going to write the 2 here and 1 by 2 is there. So this 1 by 2 I want to move inside. So root of 4. What is answer? The answer is a 2. So this 2 is going inside means I want to write as a 4. So here is a, I will going to move as a 2 here. This 2 is I have moved inside. Okay, similarly if it is that one, if direct, if I will going to move it 2 means, so I said about that 4 I need to write. So 4, yes. So 4, then here is a 4. If you are not understand, I will repeat again. See here. So the 2 is over, denomination 2 is there. The 2 is a common for that this term as well as this term. Yes or no? It is common. So what I will going to write, simplify. Here I will going to write as a 2. That's all. Here 1 divided by 2. So 1 divided by 2, root of this answer is coming. Next step, this 1 by 2 I need to go inside, move inside. If I want to move inside means what do I want to write? So root of 4 it is equal to 2. So my side is a 2 is there. Otherwise simple to say 1 by 2 means 1 by that one. So I want to go inside the root means I need to write as a 4. I need to write as a 4. Okay. So you can move here. So 1 divided by 4 you can come here. 1 divided by 4 you can come. Okay, so numerator 4, denominator 4 cancel, numerator 4, denominator 4 is cancel. This 4 is go inside the bracket. If it is inside the bracket means 2 power squared. So as usual 4 only. That's all I will write. So 2 power squared as usual 4 only. So simplified the equations. That's all. So I'm getting on that one. After completed this point, what is that one? This is a K1 and this is a this is called a K2. K1 value I found and K2 value I found. So this is the steps I have completed so far. I will repeat again step number 1. Okay, it has that 4 point. One is a KVL I am apply, then after that apply d by dt, then divided by L, then shorthand by that d by dt is equal to d. I will going to replace. That's all. From the fourth equation, you will going to find out what is a term. So here is a 1 into d squared. So 1, b term or by L, c term, then quadratic equation formula. This is a formula mathematics derived already. That formula. In that formula, a value, b value, and c value substitute. Then I will going to substitute. Okay, after substitute, I will going to get this. This is a box is I am getting. So this is k1. This is a k2 over. K1 I have found and k2 I have found. So this is about that one I of t equations. So I of t is equal to c1 e power d1t plus c2 e power d2t. So this is a solution of the I of t in the RLC circuit. In the RLC circuit, I need to how this equation number 5 is came. That is my first question. How the equation number 5 is came means, see that one I of t is equal to x1 plus x2. X1 means c dot e power d1t, x2 is equal to c dot d power d2t, d2t. So summation of x1 plus x2 is equal to this I of t. So this is equation number 5. So this is equation number 5 directly I have written here, x1 plus x2 terms. Okay. So x1 is equal to constant into e power d1, constant e power d2. Okay. So this is the terms. Okay. So here k1 value and k2 value I have written. Okay. Then next one, this is called roots. This is a root. This answer is coming or not? It's called a name is called a roots. The based on the roots, depends on the types of the roots wise. The k2 is a maybe positive or k2 is a maybe negative. K2 is equal to 0. You will going to substitute. If you will going to substitute it to, you will going to find out the over demand, under demand, and the critical demand. One more question they will ask you here possibilities. If k2 is a positive means what is the demand? It is a sorry damped ratio. Okay, damped ratio, it is over damped ratio. Okay, then k2 is equal to 0 means what a critical damped ratio. So you will going to write about that one mark questions. So let's we go ahead on that one. K2 I will going to substitute as a positive. If it is a positive means, okay, this is a terms, so greater than that one, this terms. Okay, r by 2l is high compared to that 1 by lc. Okay, then what I will going to do, so here, so d1, so here you can look at this side, d1 is equal to k1 plus k2, d2 is equal to k1 minus k2. This is equation number 6. So it's a constant equations. So don't substitute it. What is k1 and k2? Just you will going to keep it in your mind. This is the equations. In the sixth equation, substitute into the fifth equation. Where is the fifth equation? This equation I of t. I of t is equal to constant c1 dot e power k1 plus k2. Okay, so d1 is over. Yes, plus c2 dot e power d2 is there. What is the d2? d2 is equal to k1 minus k2. Here I have written or here I have written. So both also same. So k1 minus k2 dot d. Don't substitute it. Enough. This was a point is enough. Okay. If you want to add and then you will going to proceed on next step. Otherwise you will going to stop it here itself. So I of the value of that over damped ray is a over. So you need not to substitute the k1 and the k2 for the simplify. So this is a point is enough. So here what I have, k2 is a positive. If it is a positive means, so r by 2l is high compared with the l1 by lc. Then next one, k2 is negative. Then after as usual, k2 value is negative. If it is k2 value is negative means r by 2l is a less compared with that one 1 by lc. 1 by LC, it is comparisons. If y means it is a negative, okay, imaginary, it will going to present k1 plus j k2. So it's a imaginary, it's a present. Then d2 is equal to k1 minus j k2. So this is a d1 value, this is a d2 value. So what is the formula? So formula is equal to c1 dot e power d1 plus c2 dot e power d2. Substitute the d1 value and the d2 value. What is the d1? D1 you will going to add. So d1 is what is yes, k1 plus jk2. d2 is equal to k1 minus jk2. Okay, this is a point you will going to substitute. Okay, yes, here I have substituted. See that. So c1 dot e power d1 plus C2 dot e power d2. Just you will going to substitute. Okay, just you will going to substitute. And after that, what is that one common terms? So e power k1, k1 of t is common, mine plus is there, here minus is there. So k1 only I will going to move outside, remaining k2 I will going to keep it on here itself. Okay, so that's all about that one. It is called underdamped systems. Then critical damped systems. What about the critical damped? Simple k2 is equal to 0. K2 is equal to 0 means what is that one? Here is the equation as well. So see this one. This is the equation. In the equation, I need to substitute the d1 value and the d2 value. So what is the d1? D1 is equal to, this is the equation. D1 is equal to K1, D2 is equal, D1 is equal to K1 plus K2, D2 is equal to K1 minus K2. This is a formula. So in the formula, if it is that one critical damped system means K2 is equal to 0, 0 you can substitute. What is that one D1? D1 is equal to K1, D2 is equal to K1, both also K1. Substitute in that one equation, I will go and write. So I of t is equal to, I of t, it is equal to, then C1 dot e power d1. What is the d1? K1. Why K1? Because K2 is equal to 0. So K1 only. K1. K1 dot, what is there? Remaining T is there. Okay. T plus. Why plus? Here is the coming to that one. C2 dot e power, what is that? D2t, D2, what is a D2? D2 is equal to K1 minus K2, K2 is usual 0, why 0? This, because that one critical resistance K2 is equal to 0, so K1 only, K1. So that's all. This is the equation. So this is the equation. Further, I want to simplify on that one. What is a common term? E power k1t, k1t is there. So take it as a common, e power k1t. I will going to take it as a common. Then open the bracket, c1 plus c2. C1 plus C2. What is the left hand side? I of t. So this is the equations. Need not to, you will going to substitute K1 value. If it is needed, then you will going to go ahead on that one. Up to this point is enough. So here you will going to stop it on the two up to this points. So let's see, we will going to see that one. Okay, equation critical damped. I have see that one. I guess C1 dot e power K1t plus C2 dot e power K1t. It is, here is a small mistakes. K1, K1 only you can write. Then C1 plus C2 into common into key power K1t. So you will go and write. Okay. So that's all. So coming to that one. So here, so K1, K2 is equal to only 0, K2 is equal to negative, K2 is equal to 0, positive, negative and 0. So based on that one, over damped, under damped and critical damped systems. Okay. And further we will have continuations. So critical resistance, you will going to find out what is a critical resistance. Okay, in that one, roots equal to 0. If it is a root value, it is a k2 is equal to 0, k2 is equal to 0, you will going to take to, you will going to find out the RCR. So let's we going to see. So what is this one? This one's, this is a k2. Yes, root of this answer, this root of this answer is equal to 0. Then root values are removed. Then what is the remaining constant? R by 2L. So remove that once. So R by 2L and then minus 1 by root of LC is there. So move the 1 by minus is move that side. So 1 by root of LC. Okay, this is the equations. R by 2L, it is equal to 1 by root of LC. Okay, so this R is nothing but a critical resistance, the numerator. So this denominator 2L, I will go to move opposite side. So 2L divided by LC. I will repeat again. So take this K2, K2 is equal to 0. So when K2 is equal to 0, you can do. So remove the root. So if you have remove the root, then what is the answer? So root is cancelled and this square it will going to remove. Then what is the value will come? R by R divided by 2L. This minus is term is there. You can move opposite side. So plus term 1 divided by root of LC. Then critical resistance is nothing but this resistance 1 divided by 2L is there. It's a denominator. You can move opposite side. So 2L is coming. Okay, further, what is that one left hand side? R only. Further, you can simplify. Okay, it's L. L is nothing but a root L, root L. So 2 into root of L into root of L. What is denominator? Denominator is root of L and root of C is there. Yes. So root of LC. So 1 is cancel. Then what is the remaining? Root of L by C is there. So simplify the answer. 2 dot 2 dot root of L by C. You can look at this answer. Yes. So this is about the critical resistance. Critical resistance. The next one. What is this one? Next one. Damping ratio. Damping ratio. Epsilon is equal to R divided by RCR. What is RCR? Critical resistance you found. 1 R divided by this answer. Okay, R divided by actual resistance divided by critical resistance. R is what is that one? Actual resistance. R divided by RCR. What is RCR? When answer 2 into root of L by C. Substitute in that place 2 into root of L by C. Yes, I have substituted. Then simplify. How to simplify? Root of L by C is there. Otherwise, you will go to C by L. You can write because here denominations. So C by L. What is that one remaining? R by 2. That's all. Answer is same as it is. Otherwise, if you are, you can keep it this one or this one. Okay, this is called a damping ratio. The next one, natural frequency. In that natural frequency, epsilon is equal to 0. Omega n is equal to 1 divided by root of LC. Okay, so this is the terms I will going to implement into that one. Yes, one I mean implement into that this place. Okay, in implement into that this place. So I want to simplify, just I want to substitute epsilon is equal to 0 into omega n is equal to 1 by root of LC. I want to substitute this terms into this equations. I will going to get minus epsilon omega n plus or minus omega n root of epsilon squared minus 1 minus 1. This term is I will going to replace into the this terms. So this is simplified terms I'm writing. Okay, minus epsilon into omega n plus or minus omega n root of epsilon squared minus 1. So this term is called alpha. This term is called omega d. This term is called omega d. Then constant into e power alpha plus omega d plus constant into e power e power alpha minus omega d. So like you will going to write about that equations, I of t equations from natural frequency. So that's all about the RLC series circuits. So once again I will going to summing up on that one RLC series circuits. Step 1 you will going to write about that one KVL. Okay, draw the circuits. Then KVL V is equal to VR plus VL plus VC. Yes. Then VR is a substitute. VL you can substitute. VC you can substitute. What is a VL? This is a VL. What is VC? This one. Just you can substitute. First equation over. Then second equation apply d by dt. So apply d by dt. So left hand side is 0. Then d by dt, d by dt, d by dt. This is second equations. Then third equation divide by L. So in the equation 2 is a divide by L you can do. So 0. Okay, L divide by L. Then this is equation number 3. Then equation number 4, shorthand. You will going to write the shorthand. D by dt is replaced into the d. So you will going to d by dt. D squared by dt means d square. This is a term is d. Okay, here nothing. So I will going to write the same. What is common? I is common. Commonly I will write. It is equal to 0. So this is equation number 4. Then step 2, implement the quadratic equation. This is a formula, minus b plus or minus b squared minus 4ac divided by 2a. A, B, C I needed. From the fourth equation, I will go to A, B, C. What is the A? 1. B or by L. C, this is the terms. So substitute on that one A, B, C in that quadratic equations. I am substituted B value, B squared minus 4 into A value and C value I am substituted. 1 divided by 2 into A. A is a 1. So, okay. So this 1 by 2 is I will going to move inside. So I will going to move inside. So root of 4 is equal to 2. So 1 by 2 you can move inside means 4. 4 you need to write. So 2 times. Yes. So already numerator 4 is there, denominator 4 is there. Now you can move, cancel. So 2 power square is nothing but 4 only. So in the equation, then what is this one? K value, K1 value. This is called the root of this value is nothing but K2 value over. So K1 value I got found and K2 value I got found. So what is the I of t in the equations? RLC C1 dot e power d1t plus C2 dot e power d2t. So this is a solution for I of t in the RLC circuit. C1 dot e power d1t plus C2 dot e power d2t. This is a solutions. Okay. Then next one, based on the roots wise, K2 is equal to 0 or K2 is equal to minus negative, K2 is equal to 0 or positive. Like you will go to damped, you can say. If it is positive means over damped, negative means under damped, negative and imaginary under damped, and K2 is equal to 0 means critical damped. Then what to do? Okay, so first K2 is positive is nothing but K2 is higher. This is high value greater than that one. Compare this equations 1 by RLC. It's a higher. It's a K2 is positive. If it is K2 is negative and imaginary means this negative is higher. Compare with this one. So you have put it on the less than. Put it on the less than. Okay, if it is K2 is equal to 0, so directly I will going to put it on the K2 is equal to 0. So what is this one? So this term it is equal to this terms I will going to write. Okay, not greater than, not less than, here is a equal to. Okay, then what to do next? So next what you want to do means D1 D2. What is the D1? D1 is nothing but K1 plus K2. D2 is nothing but K1 minus K2. It's a constant one. Okay, in that d1 value and d2 value substitute into that sixth equation, it substitute into the fifth equations, then you will answer. This is your answer. Okay, if it is a K2 is positive, if it is K2 is negative means what about that d1 value and d2 value? So K1 my, okay, I mean it's imaginary, so K1 plus J into K2, d2 is equal to K1 minus J into K2. So this is equation number 6. As usual 6 you can complete it, then substitute the 6 into the fifth equation. Okay, when you will going to substitute in the d1 place and the d2 place, then you will going to substitute c1 dot e power d1 d1 dot t plus c2 dot e power d2 dot t. Further you can simplify what is the constant common, e power k1t is common, remaining terms you will going to write. Okay, next one, critical damped systems. If it is critical damped system means K2 is equal to 0. If it is K2 is equal to 0, what is the equation? K1 plus 0 plus K2 plus K2 is equal to K1 minus K2. So it's 0 0. So K1 K1 only. So okay, then substitute into that one, C1 dot e power K1t plus C2 dot e power K2t. Like you will going to write. Okay. So leave it, C1 dot e power K1t plus C2 dot e power K2t you can write. Okay, so that's all. And one more point, um, so here is over damped means I of t versus the t. Okay, with respect to time, see that curve, it is a over damped. Over damped. Good. Next one, under damped systems, it is a moving plus and minus, moving plus and minus, then saturated, plus and minus, sine waveform. Critical damped means it is not reached to the 0. If it is reached, it means over damped, it is not reached to the 0. So that is about the critical damped waveform. Okay, and then critical resistance find out, damping ratio, natural frequency. Critical resistance means this roots equal to 0, K2 is equal to 0, then simplify the answer, only can needed R only, then that's all. Damping ratio is nothing but epsilon is equal to R by RCR. I mean R is actual resistance, divided by this RCR you can substitute, this is called a damping ratio. Natural frequency omega n you will get is called a denoted. What is omega n? 1 divided by root of LC. Okay, and the epsilon is equal to 0. So this terms you will going to replace under this terms, then you will going to get minus epsilon into omega n plus or minus omega n into root of epsilon squared minus 1. Okay, so this is a, I want to epsilon squared minus 1, so change the sign, so 1 minus epsilon squared, so minus is coming on the outside, so if it is minus is replaced into the j. Okay, this is called to omega d. This is called alpha. K1 dot e power or K1 or C1 or K1, whatever, it's a constant, dot e power alpha plus omega d. Okay, alpha plus omega d plus K2 dot e power this alpha minus omega d. That's all. So this is about the simplified equation for the natural frequency. So this is about that over about RLC, transient response. So let's we go here, go ahead on that one RLC. Okay, so far I have discussed about that one type of method. Through the summing up method, I will going to simply I will solve. So I will going to sort recap about RL. What is RL? There is a two derivation is there. Okay, one is a with DC excitation or a without a DC excitation, or it is called a free source. What is the summing up on that one? So this is summing up about that one. What is that one? First, draw series RL circuit. Okay, then followed by V is equal to VR plus VL. Yes, VL is equal to substitute L dot di by dt. Okay, let's we see. This is draw the circuit. V is equal to VR plus VL. VR is equal to nothing but I dot R. VL is equal to what is this? This one L dot di by dt. So this is about the equation number 1. So T we will going to with respect to T I will going to write. Then equation number 2, what how to derive, divided by R you can use. Otherwise L you can use. Okay, I will go ahead on the R. So first equation I want to divide it with the R. Okay, first equation divide by the R, divide by the R. Where is the first equation? So V by R, then divide by R, the R is cancel, I of T. Okay, here is a L by R, I will going to write. So rearrange, so rearrange. So di by I needed. So let's we go ahead on the step number 3. Rearrange. Apply the integral. Apply the integral. Rearrange. Yes, di by I. Why di by I? 1 by x integration. Integral 1 by x. I want to x dot dx. If it is there, x is there, then it is called as a ln x. So that's why I want to rearrange I. Here is what is I denomination minus I. So minus ln x. Minus ln x, this is a x value, minus ln x value. Right hand side integral, if I will go to integral R by L, integral dt, so means t only plus constant. So this is about that is step number 3 is over. Integration. What is the fourth step? Fourth step, substitute the t is equal to 0. Find the k. Find the k. Substitute it. So t is equal to 0. Where is the t? 0, 0, 0, 0, 0 into anything 0. Then k is equal to minus ln v by r. Yes, written here. So this is step number 4. Step number 5. What is this one? 4 is substitute into the third one. 4 is a k. Substitute into the third one. Okay. Third one is a k value can substitute. What is this one? This is the answers. Minus ln v by r. Substitute into this place. See here. I have written here. Where it is? Here I have written. Then next one, what I want to do, this is a minus ln v by r. Move into the another side. Minus is move another side plus. Okay, then this one, rearrange the sign. So sign is I want to change, plus, minus, minus. Then a ln minus ln b. Ln a minus ln b means a by b. This is a term, this is a b terms, a divided by b terms over. Then I want to take the anti-log. If I will going to take the anti-log, ln is removed, e power right hand side, e power this terms. Okay, from the terms I need only I of t. Then simplify. Then this v by r you can move first to one opposite side, and after that this term you can change into this sides. Yes, I have moved the v by r in opposite side, and after that here is minus I of t. This minus I of t is move the opposite side plus I of t, and this term is a plus term, move opposite side minus. So v by r minus this term, it is equal to I of t. Which one is common? V by r. It's a common. Then 1 minus. So this is called I of t. I have found. I have found the I of t. Further simplified, tau is equal to L by r. Substitute. One more question. What is a tau? L with respect to the resistance and inductance. L by r. L divided by r. Okay, if it is the resistance and the capacitance, what is a tau? RC. RC. Okay, that is one more question. Okay, L by R. So replace, then this is the answer. So this is a method you will going to derive the derivation on the RL transient response. This is simplest summing up. And further you can continue. What is that one? VR, VL, you can go to find out what is the VR, Ohm's law, I int R, VL, L dot da by dt. Substitute this I value into this place, differentiate one time, then you will going to get the VL. I need power. Power is equal to total power. Resistance power plus inductance power. What is the resistance power? PR is equal to VR into I plus PL is equal to VL into I. Okay. So this is a method we have ever seen. Okay. You have see this is a step. Here is a step number 6 is I of t you have found. I of t find out. Okay. So here do you use any homogeneous non-homogeneous of the equation comparison? No, you are not used any homogeneous non-homogeneous equation comparison based, you are not derived. If it is that one, that is another possibilities method also there. You will going to compare. Okay, instead of these steps, instead of that one, step number 1 to step number 6, what is your role? Find out the I of t is only role. You may be compare with the non-homogeneous and homogeneous to find out the I of t only. What about that one? This remaining, this is a common. Why? Because VR is equal to I int R, VL is equal to L dot di by dt. Then P is equal to PR plus PL. This is a common. Okay. So do I compare with that one any homogeneous, non-homogeneous? No. So that is that or this is a derivation 2 is available. So you may alternative derivation I will show you. Alternative method you may be go ahead. What is alternative method? To find out the I of t only. I of t I will going to find out the I of t. See that one I of t I will going to find out. What is alternative method? I will going to complete the step number 1. Okay, I will going to complete the step number 1. KVL is equal to V is equal to VR plus VL. Okay, VR plus VL. Then in the equation divide by L. As usual step number 2. As usual step number 2 divide by L. Yes. Okay. Then step number 3, what I did, rearrange integral. I don't want to apply here. What is alternative? Non-homogeneous. Source is present. If it is source is present, I will going to compare with the non-homogeneous equation. This is the equations. Two equation. Here I have put it on the box. Two equation. This second equation is this. Okay, this is two equation. What is this equation? Dx by dt plus px equal to q. Then I or it is called x. X is equal to this are terms. Okay, this is called a box is mentioned about non-homogeneous. This non-homogeneous I will going to compare. So first equation I will going to compare with the 2. Okay, what is a p value? This is a p value. This is a q value. Then p value and q value I have right here. Then substitute into that one. These two equation is same. For your understanding clarity purpose I will go to write. Here is a P, you can substitute. What is a P? R by L. What is a Q? V by L. So P value and Q value. P is here, Q value is here. That's all. You will going to substitute. If you are going to substitute, then I of t is get. You are getting the I value directly. You will going to get the I value directly. Then in the I value, as usual, t is equal to 0. Then I is equal to 0. Substitute. Further simplify I value. Then you will going to get the I value. What is I value? This is equation number 7. I is equal to V by R. Open the bracket. 1 minus e power minus R by L into t. This is the 7th equation. See that one I. V by R into 1 minus e power minus R by L into t. V by R into 1 minus e power minus R by L into t. Same equations. Same equation. Alternative methods. V by R. 1 minus e power minus R by L into t. Okay. Same methods. Okay. So this is alternative method. You will go to derivation. Alternative method. You will going to do on the same derivations. So next class we will going to see about this alternative methods. Okay, same derivations to find out the I of t. I will show you. Here, yes, one point. What is that one? There is a two equation. One is a DC excitation. If it is DC excitation means you will going to compare with a non-homogeneous equation. If it is a free source, This is a free source. If it is a free source means compare with the homogeneous. Previously non-homogeneous, here is a homogeneous. That's all. So this is a alternative derivation method.